Hello, myself Naveen Kumar Sani. In the course Wireless and Mobile Communication, today we are going to discuss one of the complex topic, that is diversity techniques and the equalization. So before starting the diversity techniques, we must know what is the diversity. So diversity is what? In which we use the multiple copies of the same signals and we transmit it. So there are different ways of transmitting the same sample copy of one copy by different ways. Okay, so different techniques are there for that. So when we talk about the transmission of the same copy through the different ways, means we talking about the different channels. So different channels are used and these different channels are affected by the different fading characteristics. So exactly the method which is used to enhance the benefit of the diversity techniques, we must know the different techniques which are used to transmit the signals. So here the diversity techniques are used basically to improve the signal at the receiver and to enhance the reliability of the message signal. Okay, so by using the more than two communication channels. So in this, as we said, the two or more communication channels. So it means we are not transmitting the same one copy of the signal by only one channel. So we transmit the same copy through the different channel or the more than one channel, and these channels are affected by the faded signal. So in this, the different characteristics of the channel is have to be taken into consideration. So in this case, the multiple versions of the same signal will be transmitted or may be transmitted and received at the receiver by the combining the all the signals. So it means in the diversity techniques we have to discuss about the diversity combining techniques so that we can combine the signals at the receiver to enhance the signal strength or the signal to noise ratio. So here in this in this slide, one of the diagram is mentioned here, in which this is the one copy of the signal and this copy of the signal is transmitted by the different channels or more than one channels. So this channel is H1, H2, H3 and so on up to Hn. So it shows that this H is representing the CIR. Okay, so this H is the CIR, or we can say this is a channel impulse response. So channel can be characterized mathematically as the channel impulse response. So the this copy of the signal will transmit through this H1 channel and this will transmit through the H2 channel, H3 channel and so on up to Hn channel. So this channel is divided by the H1 to Hn. So in another way of saying the same thing is the same copy of the signal is transmitted with a different channel or different CIR, or we can say these are the different components of the channel. Okay, so different components, or we can say the different multipath of the components. So multipath component of the channel can be represented as H1 to Hn. Then this, before receiving this signal, it is here the some interfering signals is also added into the desired signal St, right? Then after addition of these interfering signals, then it is again there is the AWGN noise is also addition into that, into the channel when it is received at the receiver, right? So this is the St, which is the desired signal, and this desired signal is transmitted with the different multiple channels, and then a noise is interfering signals is also added into that due to some obstacles into the environment, due to the fad, due to the rain, fog and so on. The various factors are there which influence the signal. Okay, then we added the AWGN. This is the additive white Gaussian noise, which is in addition into that signal, and Y1 to Yn, these are the received signal at the receiver. So these signals are used for the combining and the equalization. So at the receiving side, we use a different combining technique of these transmitted signal at the receiver, and we select or we select the best SNR value of the particular signal. Okay, so the finding the best SNR value, or we can say how we can amplify the signal at the receiver. I mean, there are various methods or techniques, right, so that we can achieve the best SNR value. Then second, we are applying the equalization. So this equalization technique is used to reduce the ISI. If signal, if any signal which is not faded or there is no ISI, then there is no requirement of the equalizer, right? So equalization is required when the signal is faded and the ISI is there into the system. So based on that, we have the diversity combining techniques at the receiving side, as we said. So what is the diversity combining? So this is the process to extract the main transmitted signal with the minimum channel effect out of many versions of the received signal. Okay, so we have to find the best signal from there, right? And we have to reconstruct the original signal from the received different multiple copies of the signals. So depending on the type of the fading, this is divided into two parts. First is the microdiversity technique, second one is the macrodiversity techniques. So in the microdiversity technique, so this is microdiversity in that these techniques are used in the small scale fading, right? So this small scale fading effect occurs which is very scattered obstacles which is very near to the mobile phone at the receiver. Okay, so this small scale fading generally occur when we have any kind of mobile phone and we have the obstacles which is very near to the receiver. So this will create the small scale fading. It means it will reduce the signal strength which is received at the receiver. So in that in this small which is affected by the small scale fading in the microdiversity technique, the solution is for that is two antennas are separated by a fraction of meter. So as we know in antenna wave propagation that antenna array is there. So when we talk about the multiple input or multiple output, so in that case at the transmitting side when we have the multiple antennas, so the separation between the antennas must be taken into that way that the difference the placement of antenna should be a fraction of the meter in the case of microdiversity and techniques. Second is the macrodiversity technique. So this technique is used into in the case when we have a large scale fading which occur due to the obstacles between the transmitter and for the receiver for the long distance communication. So in this case the antennas are quite far apart and not shadowed is there, but mobile improves the average SNR. Okay, average SNR on the forward link. So in the microdiversity technique, we use the instantaneous SNR value of the signal, and in the case of macrodiversity technique, we use the we found the average SNR of the average SNR of all the received signals, right, at the receiving side. So based on that, the diversity different diversity techniques as we discussed just in the previous slide, it is broadly there was a broad classification of that. But when we talk about the diversity, so various ways are there for the diversity. So first one is the space diversity, right? So which is very important in the wireless communication system. So we must know about that. So space diversity, which may be the microscopic or the macroscopic diversity is there, and into that the space separation of the space separation of the antennas, right, must be half of the wavelength. So whatever the frequency of the signal we want to transmit, so in that case the separation between these antennas must be half of the wavelength. Okay, so what is the requirement for that is so that we can receive the signal which is uncorrelated signals, right, at the receiving side. Second one is the polarization diversity. So this polarization diversity is completely based on the polarization of the signal, polarization of antennas. So if we have the horizontally polarized antenna at the transmitter, then at the receiver the horizontal polarized antenna must be there. And at the this transmitter, if we have the vertical polarized, then the at the receiving side it also have the vertically polarized antenna. So polarization have to take care of all these things. Then antennas can transmit either in the horizontal and vertical polarization. So both the waves are transmitted simultaneously, okay, and receive the signal which exhibit uncorrelated fading statistics. Okay, so same method is there, but same concept is there to get the uncorrelated fading statistics. So in maybe the space diversity or maybe the polarization diversity. Third method is the angle diversity, or you can say third classification. So in that angle diversity, as we know, the signals which is transmitted from the transmitter and which is received at the receiver. So transmitted signal will be transmit and it will follow the different paths, right? So this is the transmitter, this is your receiver, maybe the mobile phone, anything else. So in that case, some signals will be the line of sight and some will be the non-line of sight, right? So it means this is the path number 1, this is the path number 2, 3 and 4. It means if we have any ST signal which is transmitted from the transmitter, so it will receive at the receiver side and it follow the different path, right? Path number 2, path number 3, path number 4 and so on. So if we see at the receiver side, these are, if this is the angle, so this is the angles, right? So so these angles, all these angles are different. So these are received at the receiver with the different angle of arrival. Okay. So this is another kind of the diversity which call it as the angle diversity. Then we have frequency diversity. In the frequency diversity, what we do? We divide the complete band of frequency into the small subcarriers and we transmit the signal through the different subcarriers, okay, and it is received at the receiver. So in this, the signal is transmitted using the several frequency channels and is spread over a wide spectrum that is affected by the frequency selective fading. Okay, so this it means OFDM is the modulation technique which is using the frequency diversity, in which the frequency selective fading channel will be converted into the flat fading channels. Okay, so as we know, the flat fading channel is somehow is desirable as compared to the frequency selective fading channels. So because the frequency selective fading channels impulses amplitudes are not constant, they are varying continuously at every instant. We cannot say so the amplitude is changing, right? But in the flat fading, the amplitude or CIR value will be same. So desirable is the flat fading, and OFDM is used in wireless communication system to convert the frequency selective fading into the flat fading system. Next example is your spread spectrum, where we use the frequency hopping or DSS. So in the frequency hopping, we are very much aware that there is a hop or a jump of the signal from one frequency to another frequency at the different times. At different times, these frequencies are used to modulate the signal at different time instances. Then we have time diversity. So here the multiple versions of the same signal are transmitted with the different time instances, right? Just like the time, this is the frequency hopping and this is a case of the time hop spread spectrum, in which the complete time is divided into the frames and each frame is divided into the slots, and in different slots we transmit the signals. In one frame, one slot is selected for the transmission of signal. In a second frame, another slot will be used to transmit the same signal. In the third frame, another time slot will be used for transmit the same signal, right? So multiple copies of the same signal will be transmitted at different time slots. So this is the time diversity. Then we have the joint diversity. So this is a combination of above frequency diversity and time diversity. The best example for this joint diversity, we can say the long term evolution, LTE, right? In the LTE we also use the concept of OFDM at the downlink side, okay, and the uplink side we use the SCFDMA, right? So here in LTE system we use the complete grid of the time and frequency domain, and in each grid we have the resource blocks, right? So this concept is very interesting, but in the upcoming lectures we will try to explain all these things about the LTE. Then we have diversity combining techniques. As we said about the diversity technique, this is at the receiving side, right? So at the receiving side, we are combining all the signals, right? Which is received by the different multipaths or the multipath components. So first is the selection combining, second one is the threshold combining, third one is the maximum ratio combining, and fourth is the equal gain combining. So these are the different combining methods at the receiver, and this is the classification of the space diversity which we have just discussed in the previous slides. Okay, so these combining techniques are there. Okay, so now come to the first one where we have the selection combining techniques. So in the selection combining technique, this is the first and most important and the simplest technique in which is based on the principle of selecting the best signal. Okay, so what is the best signal means? Best signal means which has the very large energy or the very high SNR value or the throughput as well. Okay, SNR value. So among all the signals which is received from the different branches of the channel or the fading channels, so this in this method we select the best signal. Okay, so these are the antennas which is received the signals, and their different gains are there. So at the switching logic and demodulator, what we do, we select the best of these. If this is the SNR1, this is SNR2, this is SNRM. Okay, so these are the multiple copies of the same signal, suppose. So in that case, if SNR2 has the best larger value as compared to SNR1 and SNRM, so in that case the output which is coming here, that is the SNR2 value, right? So this value will be the best SNR value of the signal. So this signal will be demodulate, decode, demodulate, and then it will be bypassing through the threshold and it will be received. Okay, then we have threshold combining. So in that threshold combining, it's a special form of selection combining technique or selection diversity that is less expensive as compared to previous one, but limited number of signals are considered for the extraction purposes using the threshold. So how it works? It works on the scanning and the feedback mechanism which is used in the threshold combining method. So what exactly happens? So as we said, different branches are used to select to find the SNR values. So out of this SNR value, this receiver has a extra circuitry which is used to scan all the SNR values of the signals through the different branches. So after in this process of SNR scanning of the SNR, we set one of the threshold value. So this threshold value can be set. Suppose, just for example, I am taking this as the 2 dB. Okay, if this is a 2 dB which is the threshold value, if any signal value which is above 2 dB, then this will be selected. If any signal strength which is less than the 2 dB, in that case it will be rejected. Okay, so scanner scan the signals and it try to find the which it is select the signals and it is compared with the preset threshold value. Okay, after selecting the that particular branch through which the largest SNR value is achieved from here, then it will be selected and it will be received at the receiver side and it will process accordingly. But after selection of the signal which have the larger threshold SNR value above the 2 dB, then after the selecting that, again scanning will occur. Okay, So after that again scanning will occur. So after scanning again it will receive at another time instance, it will achieve the another SNR value. Means it will select the next branch which has the large SNR value. So continuously scanning and then compared with the threshold value and received at the receiver. So this process continuously occur into the threshold combining method. Then we have equal gain combining. So equal into that method equal gain combining, there is the EGC. So it is better than the selection diversity and it is almost good as the maximum ratio combining method. So but it's less complex of the signal processing and feedback path technique is used into that, and the idea behind that is mentioned here. When if we have the M branches and these all M branches are receiving the signal from the from the channel, and there is the branch weight. So we provide the branch weight, equal branch weight, because this is equal gain combining. So we provide the equal branch weights onto each branch, and then the condition for that one is the co-phase. So all the signals must be converted into co-phase, and after the co-phase it must be sum up. So after summation the output will be achieved, or we can say we do the averaging of the SNR values, which is better as compared to the selection combining methods and the threshold method. Then we last one is the maximum ratio combining. So into that maximum ratio combining, so this is for noise limited systems which is without interference, okay, and the MRC results in the best SNR, right? So here all the incoming signals from all M branches, sometimes we call M branches as the M finger system, which is used generally in the rack receiver, right? So which are weighted according to their individual signals, right? So based on the individual signals, we this system will provide the different weights, right? Weights, or we can say that we amplify the signal in this way, amplification factor. Okay, so in this case the voltage to noise power ratio and then added. So if we have different SNR values, so maybe if any of the signal which is passing through the one of the branch and which has the less SNR value, so we provide the large weight to that. If at this branch we are receiving the better SNR value, so we provide the less weight to that. Similar to that, if this branch has the best SNR from the channel, so we provide the less weight to this. So overall picture is that we combine all these signals at this block, we provide the branches, and these branches will be based on the voltage to noise or the signal to noise ratio which is achieved from these different branches. So after that we co-phase, we provide the co-phasing of into that, and then we sum all the signals, and then the detection will occur based on the threshold, and then again output will receive the best SNR signal. So this is the benefit of the maximum ratio combining, which is one of the best part which is used in the wireless communication system, and in right now in molecular communication system also this maximum ratio combining method is used, right? Next is channel estimation technique. So channel estimation is the estimation of the channel at the receiving side. So channel estimation is an auto-aggressive process that may be performed with a number of iterations, right? So auto regression model which specifies that the output variable depends linearly on its own previous values or some of the known values. So it depends when we do the channel estimation. So it depends that when we estimate it, it depends that we know the channel condition or not, right? So channel condition can be known at the receiving side by transmitting the pilot signals, right? This is the main concept in the wireless communication system. So it depends if we know the channel condition or it is not predictable the channel conditions. So based on the channel condition we estimate that. So channel estimation is the estimation of the channel impulse response CIR at the receiver, as I said. So there are basically the three techniques are there of the channel estimations. First one is the CSI based. CSI means channel state information based, where we use a pilot or training sequences based method to estimate the channel at the receiver, right? So as I said, this is your transmitter, this is your receiver. So this is what? This is a channel, or we call it as a CIR, channel impulse response, right? So we have to predict this H, or we have to estimate this channel H at the receiver side. So after receiving at the receiver side, we transmit the feedback to the transmitter, and then according to the channel condition, this transmitter will transmit the signal. So important point is the CIR, or the you can say channel state information at the receiver. Second method is the blind statistical data or prior knowledge based. Uh, if the transmitter is predicting that channel condition is so and so, so based on that, blindly yeah, this transmitter can transmit the signals. Semi blind, it depends on the condition of the transmitter and receiver, again to determine the what is the channel condition. So there are different methods for finding the channel condition at the receiver as well as at the transmitter side. So if both the terminal both the equipments know the channel condition, then it is easy for transmitter to transmit the signals. So channel impulse response estimations are there, which is simple calculation is there that I'm not going into that, because there are different versions of the different versions of the signal is there, which is transmitted through the different channels. So at the receiver, the delayed versions of the signal will be received at the receiving side. So in that, the impulse response HE is the time varying and can be represented as this one. So this is simple representing, this is our desired signal which we want to transmit, and this is the channel through which this signal is transmitted, and the AWGN noise is there. Okay, so in this case, this is a received signal at the receiver. So next state estimation is based on this one. So this is Hn plus 1 is equal to A is the amplification factor into Hn plus Wn. Okay, so the next stage of the channel, right? So A is what? This is a coefficient value to estimate the next channel here. So correspondingly Hn plus 1, n plus 2, n plus 3 and so on. Then in equalization techniques, in which next is equalization technique, in which the equalization is the reversal of the distortion incurred by a signal transmitted through the channel. So as I said, the equalization is used to minimize the ISI, right? So for that one, we have the different methods. So or the different techniques in the equalization. So this equalization is nothing but the inverse channel filter. Okay, so it shows here that is the SN, then we have a distortion signal here F, and this is the channel, and then we have added the noise, this is the receivers. So this is the equalizer which we are providing. So equalizer is nothing but the inverse of the channel, right? So this is the method by which we can reduce the ISI. Okay, then at the detection side, we can use a meshed filter, one of the method for minimizing for filtering the signals. Then based on the threshold, we select the desired signal which was transmitted through this one. So channel equalization is very important. The basic structure of adaptive equalizer is there. So where we provide a different weights to at the received signal, and we use the jet transform, inverse jet transform into that. So mathematics is there. So we have to simply understand what is happening into that, right? So this is the equalizer, then we provide the weights to that equalizer, different weights are there on the branches. So when we combine all these equations, then this term we are getting, and error we can find that dk, and this is the received, and this one is the detected at the before just reception. So these differences are there, and this is the error, mean square error we can calculate from this formula. So by this formula we can also calculate the mean square error. Then we have the autocorrelations. For that, how to find the autocorrelation for the different functions. So this is the mean square error which we have to be optimized so that we can reduce it, minimum mean square error, so that optimally we can use that. Adaptive equalizer is also one of the method. Decision feedback equalizer is another method. Different circuitries are there for this case for the equalization to reduce the ISI. So in detailed version you can study through the our Rappaport book. It is mentioned very clearly into this all the equalizers which I have discussed here. Then another very important book is the Open Dalal, which is the reference book. Okay, thank you very much.